Hello guys, welcome to the channel. In this particular video, we will be looking at the problem good subtrees. So let's see what it says. Here is the problem. It says that you are given a root node of a binary tree and each node of the binary tree is assigned a value. And you are also given an integer k and you have to return the count of good subtrees. But what is a good subtree? A good subtree is a subtree such that the number of distinct values in this subtree is less than or equal to k. Now one note is given here. It says that subtree of a node consists of that node and all nodes of the subtree of left and right child of that node if they exist. Let me explain this. So it says that since it is talking about subtree of a node, this means that with every node we have one subtree associated with that node, right? So let's try to draw the subtree for this node according to the definition. So the subtree of this node will be the node itself and the subtree of left and right child if they exist. So you can see that there is no any left and right child. So the subtree is going to be the node itself, right? Similarly, the subtree of this 5 and these two nodes is going to be this and this one. Okay, let me erase this. So subtree will be this. Now let's try to write the subtree for this node. For this node, the subtree is going to be the node itself and the subtree of left and right child. So the subtree of left child is going to be this and there is no any right child, right? So this is the subtree for this particular node. What about this node? So for this node, the subtree is going to be the node itself and the subtree of left and right child. So the subtree is going to be these two, right? Now let's try to build the subtree for the root node. For the root node, the subtree is going to be the node itself and the subtree of left and right child. So these are the subtree of left and right child, right? So let me write these. I have the node with value 2 and I have the node with value 5 and 4. Okay, so I have written wrong here. Let me correct this. The value should be 4 here. Now these are the possible subtrees for the given tree. I hope you are able to understand this thing. So what we need to do is now let's try to solve this particular example as you have understood the concept of subtree. You can see that according to the problem we need to count the good subtrees, and a good subtree is a subtree where distinct values is less than or equal to k and the value of k is 2 here. So for this, first of all, let's try to count the number of distinct values. For these three nodes, we have the number of distinct value as 1. For this subtree, we have the number of distinct values as 2. And for this subtree, we have the number of distinct values as 3. And for this subtree, we have the number of distinct values as 5, right? Now, as we have written the number of distinct value, so let's check for every subtree. You can see that there are four subtrees for which the number of distinct values is less than or equal to k, right? So 4 is going to be the answer. Now I hope you have understood the problem well. So let's talk about the solution. Here I have written one example, and for this example, this is the binary tree and this is the value of k is 3 for this particular example, right? Now you can notice one thing from the previous problem statement, that we are always concerned about the number of distinct values for each subtree, right? And with each node we have one subtree associated. This means that for every node, once we have got the number of distinct values, so our task is done. We just need to count we just need to check if the distinct value is less than equal to k. Fine. And whenever we talk about the distinct values, so the first thing that comes to our mind is a set. Okay, now if you don't know, a set is a data structure which is used to store the unique values, right? Fine. So once we have got the set for each value, we just need to check one thing, that if set dot size, because set dot size is going to represent the number of distinct values, right? If set dot size is less than equal to k, in that case my answer is going to be increased, right? Fine. Now let's try to write let's try to write the set for each value here. Let me change the color to yellow. So for this node we have the set as 3. Okay, it's not visible, so I'm going to take the black color instead. So for this I'll write 1 as the 3 as the set, and for this again the set is going to be a single element, for this 5, and for this the set will be 4, right? And what about this node? For this node the set is 2, 5 and 4, right? And for this the set is going to be 2 and 3. You can see that for this node the subtree only contains two distinct values. And what about this one? For this one we are concerned about the subtree of like the number of distinct value in the subtree, right? So the values is going to be 1, then 2, then 3, then 4 and 5. These are the values that we have. Now you can see that we have got the set for each value, each node. So for each node we can just check this condition, right? And we will get our answer. Now can we try to build a relation between the node and the child? Let's see that. Once we have got the answer for left and right child, you can see that we are just performing the union operation here. We have 2, 3, we have 2, 5, 4, and we are just performing the union operation, and we are adding the current node. How it's going to work? So let's say we have a function solve, and this function is going to give me the set for each value, the set for this 1, 2, 3, like for each node this function will give me the set, right? And so this way the return type is going to be a set, right? And I'm just concerned about getting the set. So what I'll do is it is going to take root as the parameter, and I will try to get the answer for left child first. So my set of left is going to be solve for root dot left, root dot left. Okay, why I'm doing this? Because you can see that if I want to calculate the answer for this node, then I have to find the answer for this set, right? Once I have got this and this set, then I can perform the union. So similarly, I can write the set for right node as well. So I'll write solve for root dot right. For this time, just don't be concerned about how this function is going to work. You can think of this function as an abstract method which is going to give us the answer, right? And now I'm going to make this smaller. So these are the function calls that we have, and this is going to give me the set for left and child, right? Left and right. Once we have got this set, so I just need to do one thing: the set of final set. I will have final set. First of all, this will be a empty set, and after this I will add, first of all I will add the root data. So I'll do final set dot add root data. After this I will add all the elements of left and right child, right? So I will do final set dot add okay, so what I'll do is I'll write add all from left. And okay, these are not the exact functions, I'm just going to represent the idea. So this is a kind of pseudo code. Add all and right. Fine. So this is what we can do, and at last, since we have got the answer for our root in the final set, so we need to return the final set as well, right? So I'll return the final set. This function, what's special about this function is this function itself is going to give me the answer for every node. But can you see one thing, that this is a kind of recursive function, and whenever we have a recursive function, so we need to write the base case as well. What could be the base case? The base case is simple, that for this 3, let's say I come to here and we have a null node here. For the null node, the answer should be an empty set because there is no node data, right? So I'll write if root is null, root is null. In that case, the answer should be an empty set. Okay, so the answer should be in return. I'm just going to represent like curly braces, so I just need to return empty set. This is the whole thing that we need to do. But hold on. While doing this, we need to check one more thing, and I will change the color for representing this, and I'll write if final set. Okay, I have written this is final set. Final set dot size. This is going to give me the number of distinct values is less than equal to k. In that case, I'll do answer plus plus, right? This is what we can do, and this is going to give us the answer in answer variable. And once we have got the answer, then simply return this answer variable, right? So this is how we can solve the problem. Now let me show you the code. Okay, so this is the code that we have, and on the left hand side I have the Java code, and on the right hand side I have the Python code and the C++ code. So I'll start with the C++ code, and now you can see that for the Java code I have a function, and the return type of this function is going to be a set, and this function is going to take these three values as the parameter. And first of all, it is checking if root is null. In that case, it need to return an empty set. Similarly, for this you can see that we are returning an empty set, and after this we are getting the answer for left and right child. And once we have got the answer, we are just doing this thing. Okay, now there is one thing that is different from the the pseudocode that I have shown you, that I am using the left set itself as the final set here. You can see one thing that, okay, similarly I am using the left set here as well. I am adding the data of right child, right set in the left set, and after that I am just adding the root value in the left set as well, and at last I am returning the left set. This is what I am doing, and I have a reference variable here. You can see that I have the reference variable. And for C++, interesting concept is call by reference, where we just need to pass the address, right? Fine. Now let me show you the Python code. For the Python code, again, there is no call by reference, so that's why I'm using answer of 0 here. So I have a reference variable, right? So this is all about this problem and the solution. I hope you have understood this problem well, and the solution and approach also. So if you guys like the explanation, then you can subscribe the channel and hit the like button. Thank you.